All right, so sorry for the delay, everybody. A few technical issues, but hopefully we'll be able to proceed smoothly from here. This is an outline of what I'm going to be going through in the talk, which is all about security of OpenDaylight. And I'm going to tell kind of a story about how I started to become involved in OpenDaylight in December 2014, the security issues that were around then, and then talk about the progress that we've made and the next steps to improving the security of OpenDaylight to make it a truly world-class open source project. So I won't read out all of the points on the outline slide. But first, I should give you just a brief introduction about myself. So I've only been involved in this community since December 2014, so not so many people would have heard of me or met me. I also have the terrible disadvantage of being on the other side of the globe. I live in a beautiful city called Brisbane in Australia, which is a wonderful place, but it has the worst time zone imaginable, which is a major handicap. But we somehow managed to work around that. My field over the last 5 years has been computer security in a wide range of roles. I worked for Red Hat for many years, managing their security response team. But my academic background is actually climate forecasting. And if you'd like to know about where we're standing right now will be underwater in 500 years, come up to me afterwards and I'll explain it to you. So my involvement, as I said, in the OpenDaylight community has been geared around establishing a security response process, responding to security issues that are reported to us, shipping patches, and then more recently trying to get ahead of the game with some proactive efforts to proactively improve security of the code base. So let's start by describing the attack surface of a software-defined network. And in sort of formal security parlance, an attack surface is a description of all the different ways that an attacker might be able to take advantage of a vulnerability in the system. So if you're looking at your mobile phone, the attack surface would consist of the baseband, somebody physically stealing it, a vulnerability in an application, etc. So what if we apply that kind of modeling to an SDN controller? Well, on the one hand, they've got a great advantage. By factoring out the control plane logic to a separate system and being able to isolate that system on a secure network, that's a great thing. It makes it much more difficult for an attacker to take control of the control plane. The disadvantage, though, is you've now created an extremely high-value target. In a traditional network, you've got all these kinds of converged devices deployed around the place. An attacker might be able to control one or two, but actually getting complete control of the network would rely on exploiting vulnerabilities in every single device. But in a software-defined network, if you can control the SDN controller, you control the entire network. So it's an extremely high-value target. And that's one of the reasons why we need to pay so much attention to security of OpenDaylight. So here's a kind of graphical depiction of that attack surface. As it seems to be that with a traditional switch or networking device, both the control plane and data plane could be exploited, whereas with a SDN controller, the switch itself is only exposed via the data plane, and the SDN controller, while it's exposed via the control plane, should be in an isolated secure network. Turns out it's not quite that simple. SDN controllers can actually be exploited purely via the data plane. And this is something that I don't think the community at large really understands, so I'll go through it in a little bit of detail. This is possible because when an OpenFlow-enabled switch encounters a packet that doesn't match any rule, it sends a copy of that packet verbatim to the SDN controller and says, tell me what to do with this packet. So if there is any vulnerability in the logic that parses that packet in the SDN controller, then it could be exploited by an attacker who's only able to pass information through the data plane. It turns out there's actually been a real-life example of such a vulnerability, which is how people realized it was the case. So the attack surface looks a bit more like this. That even though you've isolated your SDN controller in a secure network, it can still potentially be exploited via the data plane. And I'll give a practical example of such a vulnerability later on in the presentation. So with that attack surface in mind, let's take a look at some of the recent vulnerabilities that have affected OpenDaylight. Oh, yes, a question. No, by all means, please. The attack surface of what?
So you talked about the SDN decoupling the control plane from the data.
Uh-huh.
So that you now have two different attack vectors.
Yep.
So in a hypervisor environment, right, you have sort of before you introduce that, your attack vector is each individual process. Right?
Yes.
Now you have an additional vector when you put in the hypervisor.
Got it.
Which is the hypervisor manager.
Yes.
In addition to the individual processor. So I was just wondering
Yes, absolutely. So we have a rating system. It's a standard that's written by NIST called CVSS, and Common Vulnerability Scoring System. And it's giving a number out of 10 to rate the severity of a vulnerability. And the criteria to be CVSS 10 is very strict. It has to be the worst possible vulnerability that a remote attacker with no credentials could just exploit and take complete control of the affected system. When we started to deal with vulnerabilities in hypervisor managers or cloud controllers, me and one of my colleagues were actually lobbying NIST saying there needs to be a rating higher than 10, because 10 says you could take complete control of an individual system. But a certain vulnerability in a hypervisor manager would allow you to take complete control of every system managed by that. And that's even worse. So same case, yes. So this is where this journey started for me. As I said, December 2014, I started to work for IIX, and my boss said to me, hey, take a look at OpenDaylight. We're thinking about maybe using it. And with a security background, of course, the first thing I try and do is break it. So I'm searching around on the internet, okay, security of OpenDaylight, vulnerabilities in OpenDaylight, and I found this report of this particular vulnerability that was sitting in a public mailing list. And the guy who'd found it was a little bit frustrated and said, well, I don't know where to report this, so I'm just going to put it in a public mailing list and hopefully someone will fix it. And it had been there for, I think, nearly 6 months, and nobody had picked up on it. And so I wrote an exploit, proved that it was actually possible to exploit it, reported it to the OpenDaylight community, and that was what started the process of creating an OpenDaylight security response team and so on. The media made a little bit of a storm out of this particular vulnerability, but it is quite a nasty one. So I'll very briefly explain how this works. The vulnerability is in the netconf and restconf APIs exposed by OpenDaylight, which use XML as a communication format. So XML documents typically are quite simple. They're just sort of structured key-value pairs. But the XML specification itself is extremely complex, and there's all these headers and metadata that you can include. And part of that is you can have a doc-type declaration, and inside the doc-type declaration, you can put external entities. It's kind of like defining constants in code. That's an entity. An external entity is where you say, we've got this constant, but the value that it resolves to should be read from this file. And you give it a URL to a local file or a HTTP resource, and when it's expanding the value of that entity, it will go and read the file and put it in there. So that can be exploited. For example, say you're sending some data to RESTconf and you say, create a service for me called X. But instead, and when it responds back, it's going to say successfully created X. But instead of putting X in there, you define an external entity, which is a file on the system that's going to actually be processing the request, and then in the response, you'll get that back. So that's the patch there. You have to disable external entities. But this is what an exploit looks like. And that's probably very difficult to see at the back. But this is a netconf session over SSH. And all I'm doing is sending it a, where's my mouse? Oh, I can't see it. Over here. Yeah, I'm sending it a very simple request, telling it to lock something. And the thing that I'm telling it to lock is this external entity that I've defined, which should resolve to the value of etc pass WD. And it's actually an invalid request, but the error message says unable to handle, and then prints out the value of the thing that I'd sent it. So now I can exfiltrate the contents of etc pass WD, which is just a proof of concept to show you could exfiltrate the content of any arbitrary file on the server. So potentially quite bad, right? So that was the first vulnerability that we found, and we fixed that. We established a process. We established a security mailing list. We got people on the security response team from all the major vendors who are involved in OpenDaylight development. And then we started to get a few reports trickle in so it was good. People were using this reporting mechanism, but of some more interesting vulnerabilities, because that one was just a very simple vulnerability that's very common in Java software, but these later vulnerabilities are more specific to SDN. So I'm just going to go through a couple of them. One of them that I found interesting is this topology spoofing flaw. And it's because SDN controllers include host tracking functionality that enables you to physically change the location of a host on the network. So you change its position in the patch panel, or you move it from one switch to another switch, but it's able to identify that it's the same system. And this is done by monitoring packet-in messages. So what it means is, because there's no authentication or authorization for this host migration, an attacker can kind of pretend to be a new host that's migrated on the network and divert traffic to that host. So This is really, really interesting. It's actually not patched in OpenDaylight yet. We'll look at a potential fix for this in a moment. And then the last one that I wanted to talk about, it's not actually in OpenDaylight, it's in ONOS. And this is the vulnerability that allowed us to realize that you could actually exploit the control plane from the data plane. And a researcher in Taiwan was running a bunch of performance tests against ONOS, including kind of fuzzing. He was just generating random values for packets and putting them through an ONOS-controlled switch at huge scale to try and see what would break. And eventually what he found was, at a certain point in his test run, the switch would disconnect from the network and cease to be controlled by ONOS every single time. And he couldn't figure out why. And eventually we realized what it was, that the switch was saying, I don't have a rule that matches this packet. It was sending the packet up to ONOS, and there was a bug in the ONOS exception handling. So because it was a malformed packet, it threw an exception, but that exception wasn't caught. And so in the end, it just bubbled up to the top-level exception handler, which said, oh, a fatal error has occurred with this switch, disconnect it from the network. So this meant you could sort of send a packet of death through a single switch and have it disconnected from the network. Quite an interesting vulnerability. So what kind of defensive approaches can we take, given these are the sort of issues that we're facing? One of them is Topoguard. So I mentioned just before that, that host migration spoofing vulnerability. And the researchers who reported that vulnerability, it turns out it affects a whole bunch of SDN controllers, not just OpenDaylight, they also proposed a fix. And they developed a piece of software called Topoguard. Unfortunately, it's tightly coupled to Floodlight, so we couldn't easily use it in OpenDaylight. But the same approach could very well be used. And it's interesting. What it does is verify the conditions of a host migration. So it wouldn't make any sense that you say there's a host over here, and now host A is over here, and then host B appears on another physical port and says, oh, I'm host A, send traffic to me, but host A is still there on the same port, physically connected. That doesn't make any sense. For it to be a legitimate host migration, it would have to physically disconnect from the network, move to a new port, and then after the move, it shouldn't still be available anywhere else. So Topoguard just verifies those logical conditions to say this actually looks like a real host migration rather than somebody spoofing it. So that's an interesting approach. Another one that's interesting is security mode ONOS. So I don't know if anyone's seen this, but it's quite similar. It's a mandatory access control system. So it's quite similar in principle to what SE Linux or AppArmor does, by saying there's this kind of set of rules that wrap an application, and it's only allowed to do certain things. It's only allowed to modify certain files, or it's only allowed to communicate on certain TCP ports. And so then, even if there is a vulnerability in the application, it's still constrained by this sandbox. So it makes it more difficult to do something really interesting with an exploit. And it's the same kind of idea, but applied to ONOS applications. So it's a sandbox within the Carafe container that wraps around ONOS applications and limits what they're allowed to do. Could this be a good approach for OpenDaylight? Maybe. If anyone has any thoughts on that matter, feel free to yell out. But I think it's a very interesting idea. Yeah? Yeah.
As soon as you turn it on, you just made your administrator's life a lot more unpleasant, right? So, I mean, if you're going to do that, then all of the OpenDaylight operators are going to be just as hacked off as your SE Linux administrators will be. So, I mean, if you do, you better make it optional.
Yeah, it would have to be optional. I think it would have to have good pre-canned rules defined. So one of the problems with SE Linux is there's so many potential use cases for a Linux server, you can't just come up with a pre-canned set of rules. But perhaps OpenDaylight is a little bit more constrained in terms of the different use cases it caters for, and you could have some pre-canned rules that would work for most people. It's a possibility, yeah. But you're right, it's definitely a drawback. So then finally, there's this diagram, and no offense, but it doesn't make any sense to me. If it makes sense to any of you, please let me know. This is a project that's being proposed as part of OpenDaylight called the Controller Shield project. And yeah, the architecture diagram really doesn't make too much sense to me, but I think where they're going with this is to have some sort of centralized security manager, kind of similar to security mode ONOS, but not so much focused around constraining the applications, but having a probe into applications. So there'd be a centralized security manager inside the OpenDaylight controller, and then you'd have modules inside each of the different components that collate security data and send it to that central manager, I think. But I'm quite confused by it. So go and have a look on the wiki at the Controller Shield project proposal on the OpenDaylight wiki, and maybe you'll be enlightened. But it's targeting the Beryllium release. So, okay, so we've talked a little bit about the attack surface. We've talked about the kinds of vulnerabilities that we've encountered in the real world, and about this sort of defensive techniques that we could actually bake into the software. But I think we all know that no matter what we do, there's always going to be vulnerabilities that will be found in the software, so we need security response. I'm lucky to have had the experience of working with Red Hat for many years, also working with the Apache Software Foundation, so I'm quite familiar with open source security response. And open source security response is kind of an oxymoron in a way, because the whole principle of open source is that everything is public, everything's collaborative, everything's freely available, and in the security world we want the exact opposite. We want information to be quarantined, we want it to be restricted to a small group of authorized individuals, and that is kind of at odds with the way that open source projects are structured. So it's a bit of a balancing act. But to distill it, generally what you need is a dedicated mechanism for reporting security issues that's separate to normal bugs. So in the case of OpenDaylight, that's emailing security@opendaylight.org. That's how most projects do it. Have a security@ email address and say, don't file a bug, email this address. That address will then go to a dedicated team who can triage the issue and respond to it and keep details private. You also need the ability to actually quickly build and ship patches. And to be honest, I'm not quite sure that we're there yet with OpenDaylight, and most open source projects aren't there yet. So I frequently report vulnerabilities to large open source projects, and most of them average around 6 months to ship a fix. Usually because that's the cadence for their next major release. They can write a patch within 48 hours, no problem. But most projects don't have a good mechanism of saying, we need to respin an emergency complete release of the software. They'll just say, oh, let's keep the details private, and we'll wait until the next major release. So I've got probably 4 or 5 major vulnerabilities in large Apache projects that I've reported that are in that state right now. The patch is there in the upstream code, but actual patched release hasn't been shipped yet. And then the last thing is you need clear documentation. So you need a security advisories page that clearly identifies what the vulnerability is, the conditions under which it could be exploited, what could be achieved if it was exploited, and which versions are patched. And we have that for OpenDaylight. So we're doing quite well. So this, again, is going to be very, very hard to see down the back. I couldn't find a good way to blow it up enough. But this is just an example of the contrast between open source security response and proprietary security response. So this is an advisory that was released by the Apache Software Foundation for a vulnerability that I reported in JSTL, which is a standard Java web library, the standard tags library. And the JSTL exists in Apache's implementation, and it also exists in Oracle's proprietary implementation. So this is the advisory that the Apache Software Foundation wrote. And they clearly described the issue, they described the impact, they described how you could work around the issue without applying a patch, the version in which it was patched, and gave credit to me for reporting it. Here's the Oracle report, where there's 6 different vulnerabilities, all of which feasibly could be the one that I reported. None of them have any description. None of them have any credit of who reported them. I don't know what the CVE ID of that vulnerability for Oracle's implementation is, even though I reported it, because this is all they give you, is this grid of information. So I think this is a great advantage of open source, that even though the culture of keeping everything open and being verbose and honest about all the details is kind of against the grain of what we need to do when handling security issues, it's very favorable when actually publishing details about those security issues and making it clear to everybody whether or not they're affected. So that's the response side of things, and that's what is kind of a baseline for most large open source or proprietary projects. You don't really have a large successful product if you're not able to ship security patches, you're not able to take receipt of reports of security issues. But what about proactive efforts? What about actually proactively trying to improve the quality of the code, trying to reduce the possibility that vulnerabilities will be introduced in the first place? And it turns out that open source projects don't do a really good job of this. And I'm an open source zealot, but I'm just being honest. They suck at it. It's really hard to even point to an example and say, well, there's one project that's getting it right. The closest that I had was OpenStack. And that's because they have two separate teams. So most projects, including OpenDaylight, have a single security team, the security response team, and it's entirely reactive. Whereas OpenStack has two teams, VMT, the vulnerability management team, which is reactive, and OSSG, the OpenStack security group, which is proactive, and it's completely public. Anybody can join that group. There's no private information because it's all about just trying to proactively improve the security of OpenStack. That's the best that I could point to. The weakness of OSSG is there's a lot of people there who kind of don't know what they're doing, a lot of people who just want to associate their name with the project and they don't really get anywhere. The best example in the proprietary world is probably Microsoft, interestingly. In the late 90s and early 2000s, they really got hammered as a lot of vulnerabilities were found in Windows Server products. They were looking really bad in the media. And so they had a top-down, very concerted response and said, we're going to bake this into our process. We will not ship insecure products. And they came up with a process called the Secure Development Lifecycle, or SDLC, which I really think is the gold standard for how this should be done. Interesting, a lot of commercial networking vendors have adopted the same thing. So Juniper also uses the SDLC, and it's a total copy of the Microsoft version, which is fine in my mind, but it's interesting. So this is the OSSG, the OpenStack security group, and there are two things that that group's produced that I think are really valuable. One is some cross-project security guidelines, where they've written down, here's all the vulnerabilities that you're likely to introduce when writing code for OpenStack, and here's all the ways that you should work around them, here's all the best practices, make sure that you encrypt communication, etc. And that's great, but it has the weakness that people have to follow it. It's like you can write anything you want into law, whether or not it actually changes people's behavior is another matter. So I'm not entirely convinced that just writing down best practice guidelines necessarily achieves too much. But the other thing that they've done is come up with the Bandit Source Code Analyzer, which is a tool that automatically parses Python code and finds anti-patterns that identify vulnerabilities. And I think that's where we should be headed, because it's completely automated. It doesn't rely on developers being educated. It doesn't rely on them following guidelines and reading through pages of best practices. It's just something that you can run against the code and say, this looks like a vulnerability. It might not be, but somebody should check it out. So this is what I think is what we should do to implement a proactive secure engineering program for OpenDaylight. We shouldn't rely on secure development guidelines, in my opinion. This is just my opinion because it's difficult to implement. We don't want to rely on developer training because it's expensive and it's very difficult to roll out in a virtual environment. So within the company that I work for, we have approximately 20 people in software development roles. I can quite feasibly train every single one of them and make it an onboarding requirement that you complete security training. There's no way I can do that for the whole OpenDaylight project. It's just not feasible. So I think what we should rely on is automated jobs in the QE or continuous integration system to catch known vulnerable dependencies. When you're writing Java applications, you typically introduce a very large number of dependencies, all of which could have their own vulnerabilities. So if any of those are known to have a vulnerability, you want to catch it. And then we should also have automated jobs that use static analysis or other approaches to identify chunks of code that look like they're vulnerable. So, go ahead.
Yeah, there already are CI jobs that do this in OpenDaylight.
There are?
Yeah, there's the Sonar type CLM report.
Oh, yes. There's a Sonar type CLM, yes.
There's some Sonar rules that can identify bad security patterns.
Yes. So that's very interesting that you mentioned Sonatype CLM. So I looked at that, yes, when the community was given a license for Sonatype CLM and allowed to use it. The problem with it is it doesn't actually fail the builds. It's something that just sits on top of it and provides you with a report. Also, Sonatype don't tell you how it works, and based on my own experience, it gives you a lot of false positives and also false negatives, so I'm not a huge fan. There's a tool called Find Security Bugs, which is an open source static analysis tool that has quite good, and I say this jokingly to people, that it doesn't have very many false positives, only about 90% of the issues that it catches are false positives. And that for a static analysis tool is really, really good quality. So I think we should apply that, and well, this is a good segue to the current status. actually. We should apply that and also an open source vulnerable dependency check called dependency check, which we'll get to. Yes, OWASP dependency check. So here's the current status. We're just stepping back a little bit here to the current status of security response, and then we'll get to what we were just talking about. So we have a well-oiled machine in terms of security response. We have a private mechanism for reporting vulnerabilities. We have a dedicated team. We have an advisories page, and we consistently send advisories to mailing lists. Here's what one looks like. They're clearly structured. You have a description of the vulnerability, an impact rating, which versions are affected. We link to the patch commits, which versions are patched, and critically, we give credit to the reporter. I can't emphasize enough how important this is, partly because security people are complete egomaniacs, but partly because this is the only currency that we have to give them. We could establish a bug bounty program and say, we'll give you $1,000 cash if you report a vulnerability, and what we'll get is 10,000 useless reports of issues that aren't vulnerabilities, and every now and then a nugget of truth, which we probably would have got for free anyway. But if you just give credit to somebody for reporting a vulnerability, this is really good for their career, for their CV, but also for people who work in consulting roles. This is something that they point to for their clients and say, look, I found all these vulnerabilities in OpenDaylight, therefore I know what I'm doing. And it costs us nothing. So I think it's really important to do. One of the limitations, though, is that the scope is limited to OpenDaylight code, not its dependencies. We looked at the scope of all of OpenDaylight's dependencies and said, oh man, how can we possibly monitor all the vulnerabilities in all of these dependencies and ship patches for all of them? It would be a huge task. I mean, I know how to do this because this is what we did at Red Hat for a very large number of products. So I could establish the workflow, but we'd need a full-time dedicated resource to staff it. This would be somebody's full-time job. So if anybody works for a deep-pocketed company that wants to pony up for a full-time security response engineer for OpenDaylight, let me know. I know some good people. But yeah, as an exception, we do occasionally handle vulnerabilities in the dependencies when they're directly reported to us and when a patch already exists and we can easily fix it. So for example, the Lithium release had already rebased to a newer version of SQLite. Somebody reported the fact that that included a security fix, so we went ahead and wrote an advisory because that wasn't very much work. But actually staying on top of that and monitoring all the dependencies and the vulnerabilities in them would be a huge job. So that's the current status of security response. In terms of secure engineering and proactive work, there was a great analysis that was performed back in May 2014. And I had the opportunity to speak to some people in January this year who performed that analysis. And pretty much what happened was they were given the time to perform the analysis and then brought back to their day jobs as soon as it was over. So pretty much none of the recommendations in that report have been implemented. But there's some really good ones in there. It's a really good report. So how are we going to deal with this? We've got this really good report that talks about what we should do. Nobody has the time. And then I saw, oh, look, the OpenDaylight summer internship program. So I wrote up a summer internship project to implement a proactive secure engineering function for OpenDaylight. And that project is now nearing completion. I was just speaking to the guy who's doing it earlier this morning, and he's just writing documentation now. He's almost done. So the next slide's going to be out of date. But the basic scope of this project is to establish those automated jobs to both catch security issues based on static analysis and known vulnerable dependencies. Also to document a threat model for OpenDaylight and improve the install and sysadmin documentation to explain what you need to do to secure your system. So here's the status, and those, sorry, the ticks are a little bit offset there, my bad. Never prepare slides running Linux, it's always a bad idea. So the automated QECI jobs are done on his local system. So he's got a local build of OpenDaylight that includes these. And there's two things. So the first one is implementing the dependency check tool in Maven. So this just catches known vulnerable dependencies, fails the build, and spits out a report. That's easy. We just need to get that merged upstream. He's already submitted the patch request to Gerrit, and it's just sitting there waiting. So if anybody wants to approve it, go ahead. More difficult is the static analysis jobs using find bugs. Because as I said, it's such a great tool that only 9 out of 10 issues that it reports are false positives. So somebody has to go through and review each of the things that it reports and say, this is a false positive, so next time it runs, it won't come up. Otherwise, you're just going to keep getting this report full of false positives. You need a way of crossing them off the list, and then the real issues, go and file a bug and deal with it. So he's created a plugin to Jenkins that integrates the Find Bugs plugin into the Maven build, but then also implements that workflow in the Jenkins GUI. So somebody can go in and mark off all the issues that are false positives and scrub them from the list. So again, he's only just got that working, and I said to him this morning, you need to document it. I'd love to show this to the community today, but if there's no documentation and nobody can download and install it, there's not much point. So that's where we are. And then finally, what's the real vision here for what we should be able to achieve? On the reactive side, we're nearly there. We've got a high-performing security response team. The thing that we're missing is the ability to handle vulnerabilities and dependencies, which is really just a resource problem. We're able to coordinate disclosure, which is really important, because one of the ways that this could all go south is if the vendors that participate start infighting and start trying to hoard information about security vulnerabilities. So say tomorrow we were to get a report of a critical security vulnerability, and the reporter said, I'm presenting this at a conference tomorrow. Sorry, I'm going to drop the information. We would have the ability to privately notify all of the affected vendors, get them to keep that information private, allow them to prepare patches for all their downstream builds, and patch the OpenDaylight upstream build itself. So that's a great capability to have. And underpinning that is geographic distribution of the team. So we have people, myself in Australia, a few people in the US, and a few people in Europe. So any time of day or night, we can get a report. Man, that is messed up. On the proactive side, things aren't so great. So the green tick there is for documentation of best practices, the threat model, etc. That's been done. Red X for remove default credentials. I don't know why we have to ship with carafe and admin credentials in OpenDaylight. I tried to remove them once as part of a security patch, and I was hit on the head hard. That was not allowed. So if anybody is more influential than me in the community, I would love to get rid of the default credentials in OpenDaylight. Security hardening features, such as the ones that I described earlier, like security mode ONOS, we don't have yet. That's probably not the top priority, but it could be cool. Automated checks for known vulnerable dependencies. Well, like I said, that's nearly there. We're just waiting for it to be merged. Same for automated static analysis checks. And then finally, security training for developers. We don't have this at all. And as I said, it's largely infeasible to actually gate access, like committer access, and say, you have to have passed this training course before you get there. I think would be really hard and would just stifle innovation in the community. But one idea that I had was actually donating some training that I've developed to the community so that people could do it on a voluntary basis. So if any of you are interested, go to javapentesting.com. This is a course that I wrote specifically around Java applications, so that all the issues that it focuses on are specific to Java. And it's a penetration testing course, so it's an offensive course, but it's targeted at people who write code. So I've gone and delivered this course to a bunch of finance companies that write Java code. And the idea is that if your developers know how to identify and exploit security issues, they'll be very unlikely to introduce those same issues in their code. Rather than just telling them academically, oh, this is an issue, you let them write an exploit, you show them actually executing arbitrary code on the server that they're exploiting, and they will never make that mistake again. So that training consists of a slide deck, but also an application, which is open source, and the application includes a bunch of intentionally inserted vulnerabilities. So you go through the slide deck through one class of vulnerability, and then you have a hands-on challenge, where you have to find and exploit the instance of that vulnerability that's in the demo application. So I'm considering donating all of that to the community so that people can go through it. And that's the end of my presentation. Any questions? Yeah. So you mean for the static analysis kind of testing, or? No, for the black box testing. Like, so that's really what Find Sec Bugs is doing. It's actually working at a source code level rather than a black box level. My concern with a lot of those commercial tools, particularly the ones that are black box, is the false positive rate is just impossibly high. So I had the Codenomicon as an example. I had the experience of working at Red Hat, where sometimes customers would run commercial tools over our software and then say, oh, here's a report. Can you go through it for us and find any vulnerabilities? And I'd spend a day going through the reports. And in 5 years working there, never once got a real vulnerability out of them. So I'm kind of have a negative attitude. Okay. Oh, you mean just fuzzing, pure fuzzing to try and introduce crashes? Oh, that could be really valuable. That could be really valuable, yeah. Sorry, I thought you were talking about sort of analysis or dynamic analysis tools. But no, fuzzing could be quite beneficial. Yep, I agree. Anybody else? Questions or comments? Oh, sorry?
Yeah, does CARAF support standard security manager, Java security manager?
It does support the Java Security Manager.
That could be useful for Mac, but it's a bit of a pain to write the policies, but once they're done.
The problem with the JSM is it introduces about a 50% performance overhead when you run it. So we had a Red Hat Java product that, how would you put it? It had a fundamentally dangerous design. Like, it wasn't badly written, it was just the whole premise of the application was a big threat from a security perspective. And so I said, okay, we need to enable the Java Security Manager by default, because there's probably going to be vulnerabilities in here that we don't find before we ship it. And we did that, we shipped the release, and then we got a torrent of feedback from customers saying, your product sucks. And I had to back off from the requirement because it was either we have a secure product or we have, a product that, yeah, can't sell. So the JSM would work, but I'd be reluctant to enable it by default. Yeah. Sorry. Yeah.
You said that you have courses on your website, or that you could
Yep.
give to the OpenDaylig community.
Yep.
Please repeat the website. I have Java pen testing.
So it's just there, javapentesting.com.
Sorry, I didn't see.
That's okay, no problem. Yes.
You mentioned that the switch will forward any packet that's now removed
Yes.
to the controller. That opens the whole service. That kind of stuff has to be analyzed from the beginning of the design phase, right? So that's the healthy process.
Yeah, so I think it's just a case of people not quite joining the pieces together and realizing that that could be exploitable, because it's not as though the attacker has any direct path into the SDI controller. It's just if the logic that handles that forwarded packet has a vulnerability in it, then it's potentially exploitable. It's highly unlikely that you get a really serious vulnerability there, like a code execution vulnerability. It's hard for me to get my head around what you'd have to do to introduce a code exec vulnerability. But a denial of service like the one that we saw in ONOS seems quite feasible. Yeah.
What is going to be done to make the design process more simple?
Well, I'm hoping that just by presenting this information to people that they realize. That's one of the things I'd like people to take away from this is when you're designing and deploying SDN networks, don't make the assumption that just quarantining the SDN controller in a secure network is sufficient. There could always be those vulnerabilities. Okay, unless there's any more comments or questions. Nope. Okay, well, thank you very much, everybody. Plane and the SDN controller, while it's exposed via the control plane, should be in an isolated secure network. Turns out it's not quite that simple. SDN controllers can actually be exploited purely via the data plane. And this is something that I don't think the community at large really understands. So I'll go through it in a little bit of detail. This is possible because when an OpenFlow-enabled switch encounters a packet that doesn't match any rule, it sends a copy of that packet verbatim to the SDN controller and says, tell me what to do with this packet. So if there is any vulnerability in the logic that parses that packet in the SDN controller, then it could be exploited by an attacker who's only able to pass information through the data plane. It turns out there's actually been a real-life example. All right, so sorry for the delay, everybody. A few technical issues, but hopefully we'll be able to proceed smoothly from here. This is an outline of what I'm going to be going through in the talk, which is all about security of OpenDaylight. And I'm going to tell kind of a story about how I started to become involved in OpenDaylight in December 2014, the security issues that were around then, and then talk about the progress that we've made and the next steps to improving the security of OpenDaylight to make it a truly world-class open source project. So I won't read out all of the points on the outline slide. But first, I should give you just a brief introduction about myself. So I've only been involved in this community since December 2014, so not so many people would have heard of me or met me. I also had to take control of the control plane. The disadvantage, though, is you've now created an extremely high-value target. In a traditional network, you've got all these kinds of converged devices deployed around the place. An attacker might be able to control 1 or 2, but actually getting complete control of the network would rely on exploiting vulnerabilities in every single device. But in a software-defined network, if you can control the SDN controller, you control the entire network. So it's an extremely high-value target. And that's one of the reasons why we need to pay so much attention to security of OpenDaylight. So here's a kind of graphical depiction of that attack surface, as it seems to be that with a traditional switch or networking device, both the control plane and data plane could be exploited, whereas with a SDN controller, the switch itself is only exposed via the data. I have the terrible disadvantage of being on the other side of the globe. I live in a beautiful city called Brisbane in Australia, which is a wonderful place, but it has the worst time zone imaginable, which is a major handicap. But we somehow managed to work around that. My field over the last 5 years has been computer security in a wide range of roles. I worked for Red Hat for many years, managing their security response team. But my academic background is actually climate forecasting. And if you'd like to know about where we're standing right now will be underwater in 500 years, come up to me afterwards and I'll explain it to you. So my involvement, as I said, in the OpenDaylight community has been geared around establishing a security response process, responding to security issues that are reported to us, shipping patches, and then more recently trying to get ahead of the game with some proactive efforts to proactively improve security of the code base. So let's start by describing the attack surface of a software-defined network. And in sort of formal security parlance, an attack surface is a description of all the different ways that an attacker might be able to take advantage of a vulnerability in the system. So if you're looking at your mobile phone, and the attack surface would consist of the baseband, somebody physically stealing it, a vulnerability in an application, etc. So what if we apply that kind of modeling to an SDN controller? Well, on the one hand, they've got a great advantage. By factoring out the control plane logic to a separate system and being able to isolate that system on a secure network, that's a great thing. It makes it much more difficult for an attacker